Okay, hello. Hope more people might show up, but if not, welcome to all of you who are watching in YouTube land. Um, so I'm just going to pick up kind of where I left off last night. Um, So I was saying that there are four issues or problems that Carnap wants to show are really the same problem, that they can all be solved together. Um, so the first one is this problem about logic or set theory. And today I'm going to actually explain exactly what the problem is. Um, and the second problem I can just write for short, ontology, right? This was the thing about spheres of being and how they're related to each other and why there's more than one. And in what sense that implies that there's fundamentally different sciences that are disconnected from each other. Um, Number three, there's a problem about language, which I described last night as the problem about like how I can tell in advance whether a sentence is meaningful. And I have to know in advance because I can't start asking whether it's true or false unless, first of all, I know it means something. Um, I pointed out that, at least as Carnap understands it, that means that we have to focus on whether the concepts that are contained in the sentence are good and whether they're put together in the right way. So there have to be rules about like how you can tell that concepts are good and that they're being put together in the right way to yield a meaningful sentence. Um, and the last one is a problem about epistemology. And it's basically the problem, like, how can science talk about unobservable entities? Um, okay, so as I said, I'm going to go back to this one now and say in more detail what it is. And then I think that's going to help me go through these other ones and explain better what's going on. Um, right, so last night I was talking about the idea of an extension of property, right? So actually for these purposes, I'm not going to have to also introduce relations. It's enough to just focus on extensions of what Carnap calls properties, um, propositional concepts, propositional functions with one predicate place. Um, so we have something like X is a rose, right? X is a rose is a propositional function that takes one object and gives you a proposition. Um, so sometimes it's a true proposition if the thing you put in it is not a rose, and sometimes if the thing you put in it is a rose, and sometimes it's a false proposition if the thing you supply is not a rose. Um, and the basis of set theory or class theory, as Russell and Carnap following Russell understand it, is that given a propositional function like this, you can talk about a new object, which is the extension of this propositional function, which Carnap writes this way. Right, so by putting this X hat out in front, we indicate that we're gathering together the results of every value of x and making that into, sorry, every value of x that makes that yields a true proposition and making that into a class. So in this case, it's the class of all roses, right? And we can give this a name. We can call this R. R is the class of all roses. And then we can say things about R. For example, R is finite. If we knew exactly how many roses there were, we could say R has so and so many members. Um, R is a subclass of the class of all flowers, etc. Um, Now, I mean, as I pointed out before, uh, pointed out also last night, depending on how you think of what a proposition is, you may think that there are like many propositional functions that all correspond to the same class in the sense that it has the same members. Um, right? Like if uh, rose is the same as a flower with such and such characteristics. But and by the same, I mean those characteristics pick out the same things that are picked out by the word rose. You might think there's two different propositional functions. X is a rose and X has characteristics, blah, blah, blah. That both they're both made true. The propositional functions are both made true by the same objects, exactly. So they pick out the same class. Or you can think about propositions in such a way that those turn out to be the same proposition. It doesn't really matter for these purposes. And this class R, as Carnap emphasizes, is completely different from a whole that's made up of its members. I mean, it may be possible to regard classes or sets as wholes that have parts, but if so, their parts are not their members. Um, and uh, you can see this using an example that Carnap gives. So here's two propositional functions. No, this one's failing too. X is a brick in this wall, right? Suppose we have a brick wall here. Little bricks. All right. So we have a brick wall, and we have a propositional function. X is a brick in this wall. And here's another propositional function. X is an atom in this wall. So the classes, the class of all bricks in this wall, and the class of all atoms in this wall are not the same class. How can you tell? Well, they don't even have the same number of members, right? There's a lot more atoms in the wall than there are bricks in the wall. In fact, they don't even overlap each other, right? Because no brick is an atom and no atom is a brick. So these two classes have no members in common. They're totally different classes. And yet the whole made up of all the bricks, I mean, I guess in a real brick wall, there's something else besides the bricks, but suppose this this wall is built without mortar. That's just bricks, right? So the whole made up of all the bricks is the wall, and the whole made up of all the atoms is also the wall. So the wholes made up of the members of this class as parts is the same as the whole made up of the members of this class as parts, but the two classes are not the same. And from that, you can tell that that class is not the same as the whole of its members. Similarly, in this case, there's something you can think of as the whole composed of all roses in the world. Now, I mean, unlike the wall, it's not contiguous, right? It's scattered all over the place. It has pieces all over the place. But it's a really big thing. It weighs a lot, because it has every single wall as a part, rows as a part. That thing is not at all the same as this class. Um, I don't know if maybe this doesn't have to be emphasized now as much as it did when Carnap was writing, because maybe I'm not sure if this applies to you or not. I'm not sure how much people learn about sets in school or in Film 9 or anything. Um, but anyway, like if you're tempted to think of a set as a big thing made up out of all its members, you should remember this type of example. That's not what it is. Um, Okay, so far that's just introducing sets or classes. I'm using the word set and class kind of interchangeably here. Actually, I think Carnap makes a distinction between them. People have made various different distinctions using those two words. Um, the things we're talking about here at Carnap, I think would agree that there's both classes and sets corresponding to these things. So it doesn't really matter. Um, Okay, so this is introducing sets or classes, and now, as promised, I'm going to explain why. From this very simple way of thinking about classes, you immediately get a contradiction. So this is how it works. So first of all, I mean, in case you're not familiar with the set membership symbol, right? This is read X is a member of A. Um, if if you think of A as a class like right? So this is the extension of the propositional function or concept. X is an A. Then when I say y is a member of this extension, that's just the same as saying that y is an A. Is that clear? I know there's only a few people here, so I don't know if I can ask if it's clear. But right, when I say y is a member of this, I'm saying it's one of the things where you get a true proposition if you plug it in there. In other words, I'm saying that this proposition, AY, is true. Um, okay, so then we should notice that it seems like some classes are members of themselves. For example, let U be the extension of X is a set. Right? I mean, this is a perfectly good propositional function. You plug in different things for X, it gives you either true or false. Um, I guess, I mean, actually, this may not be obvious at all, but let's say we're pretty sure that ordinary stuff like roses and walls and whatever are not sets. So when you plug those in, you get false. But if you plug in the set of all roses, you get true because that obviously is a set. Maybe I should say class instead of, whatever. As I said, I'm using them interchangeably here. Okay, so in particular, one thing that will give you a true proposition if you plug it in here is U itself, because U itself is a set or class, right? So when you plug it in here, you get U is a set, and that's true. Therefore, U is a member of itself. right? Because U is the class of all things that you get a true proposition when you plug it in here. And U, when you plug U in there, you get a true proposition. So U is a member of this class. So, I mean, that's a little unusual though, right? That is, um, most classes are not members of themselves. At least, again, assuming we know that things like roses and whatever are not classes. I wonder what happened to the camera here. Something bad. It's not very good either. Sorry. See the cat. Oh, all right. Hold on a second. I'm having technical difficulties. Thank you. All right, that's good enough. Okay. Um, all excitement. Right. So I was saying, although this is true of you, it's like not true of most classes. They're mostly not members of themselves. Like again, we think at least that the set of all roses is not a rose. That would be weird. Um, uh, so like that set we had before that was called capital R, right? This means is not a member. R is not a member of itself. U is a member of itself. Okay, so far so good. There's no contradiction yet. I have to bend down and get the eraser that fell. But now consider this propositional function, right? This says X is a member of itself. So that's a propositional function. If you plug in U, you get a true proposition. U is a member of U. If you plug in capital R, you get a false proposition. R is a member of R. So we can form sorry. So I should be talking about this propositional function. X is not a member of itself. Right. So then it's the same as I said, but the opposite, right? So if you plug U in, you get a false proposition that says U is not a member of itself. That's false because U is a member of itself. If you plug in capital R, you get a true proposition because capital R, the set of all roses, is not a member of itself. So, so we can talk about the extension of this propositional function. And notice that even though X occurs here twice, there's only one argument place, right? That is, you only have to plug in one thing. It just gets mentioned twice. So this is still just a property, not a relation in Carnap's terminology. Okay, so we know one thing that's a member of this class, namely the class of all roses. And we know another thing that's not a member of this class, namely the class of all classes or all sets. Yes, exactly. Um, if you're familiar with the barber paradox about the barber who shaves everyone in town who doesn't shave himself, you probably already see the paradox coming, right? So call this, this is why I keep saying capital R, because unfortunately I want to use R for this. Why do I want to use R for this? This is called the Russell set. And the paradox that's going to come out of it is called Russell's paradox or the Russell paradox. Um, and then we ask, is R a member of itself or not? So suppose R is a member of itself. And I'm going to prove, so the first step, we don't get a paradox yet. The first step is to prove by contradiction that this is not true, right? And well, it's easy because suppose R was a member of itself. So that's what we're assuming for the sake of argument. Well, so R is a member of the set of all sets that are not members of themselves. And therefore, remember that oops, that's completely off. Remember that whatever A is, when I say Y is a member of the class of A things, that's just the same thing as saying that that Y is A, right? So in this case, A is not a member of itself. So if R is a member of this class, that means R is not a member of itself. And that contradicts my assumption, right? Because I assumed for the sake of argument that R is a member of itself, but I ended up with a contradiction. So that means so far this just proves that R is not a member of itself. It's not a contradiction yet, but now assume R is not a member of itself. Well, so if R is not a member of itself, that means it's not the case that R is a member of this set, right? So if I write not like this, I could say, and therefore, it's not true that R is not a member of itself, or in other words, R is a member of itself. So now we see that no matter which of these I assume, I get a contradiction. But by the law of excluded middle, one of these has to be true, and therefore, no matter what, I have to get a contradiction, right? So there is no consistent answer to that question, whether R is a member of itself. So the assumptions that produced this, that allowed me to write this down, must be inconsistent with each other, right? I did something wrong, and yet what? It's hard to understand, right? Because I didn't even bother to say any axioms or anything because it just seemed so obvious. Take any propositional function and think about all the things that would make it true. That's the extension. And yet you see that that simple way of thinking is inconsistent. It leads to a contradiction. That's the Russell paradox. And I mean, it's not, there are a lot of other paradoxes you can get in set theory. I think in some sense they're pretty much all versions of the same thing, but in any case, this is the famous one. Um, uh, Frege, having just published the first volume of his monumental Grundgesetze der Arithmetik, right, the fundamental laws of arithmetic, um, uh, um, got a letter from Russell saying, "Oh, I really enjoyed your book. Um, however," and it's a very short letter, and it says, however, it seems that your axiom 5 is inconsistent. And then he shows how you can get this paradox in Frege's system. And Frege wrote back and said, arithmetic totters on its foundations. Right? Like Frege didn't know what at first didn't know what to make of this. Later on, he thought about it a lot and he came to certain conclusions about that arithmetic wasn't really part of logic or whatever. But that's not how Russell reacted. So Russell said, yeah, we just have to fix this up a little bit. There must have been some simple mistake in the way we were thinking about things. And like from a technical point of view, what you do is um, you the same thing that Carnap has been talking about in this book. Whenever you introduce something like this, you're never allowed to put it back on this side, right? So like uh, the propositional functions that you use to get classes in the first place can't themselves mention classes. Um, so in particular, this one is completely ruled out. There is no such class. And it's because there is no such propositional function, basically, right? Like that is, and this is where we're getting to what I call um, this is getting back to what I called number three on Carnap's list. Like, evidently, this, which we thought made sense, doesn't make sense. Right. Again, in other words, if you just say it's always false, you'll still get the contradiction. It doesn't help to say it's false because remember what we showed was whether it's true or false, you get a contradiction in the case in that one case of R, right? So it's not enough to say that this is always false. You have to say it's neither true nor false. I think, I mean, I'm sorry I erased it, but you could see in the proof that, right, that again, the way it worked at some point was the law of excluded middle. I said, and either this has to be true or it has to be false. And either way, you get a contradiction. So instead, you have to say, no, this isn't true or false. And the way Russell and Carnap understand that is it isn't true or false because it's meaningless. This wasn't the right way to put concepts together to get a meaningful propositional function in this case. Um, so like you can never either say or deny of an object that it's a member of itself. And in Russell's system, the theory of types, the way you ensure that you can never say that is again that you introduce classes or sets in steps. You start out with individual objects, and then you introduce classes or sets that are just classes or sets of those objects. So you have propositional functions that talk only about those individuals, and from those you can form classes, right? And since those individuals themselves, none of them are sets, none of them are proper arguments to put here. So you can never say this. And then you can form another layer of classes of the original classes. And those also are, you know, are going to, they're also going to talk about classes, but they're not going to talk about classes of classes. So again, like if you have a symbol for a first level class here, um, sorry, if you have a, you can't have a symbol. If you have a symbol for a first level class here, you can't have a symbol for a first level class here. It has to be a second level class. And so again, you can't get the same thing here and here, and you can't say this, and therefore you can't get to the paradox. Um, I think I could have been clearer about explaining that. Does anyone want to ask a question about that? I know there's only a few of you, but some of you are good question askers. We're here. Have people, is this touched on Phil in Phil 9 these days?
I don't think so.
Um,
No, not at all.
uh, all right. Well, so I guess I'm doing my job by introducing it. It actually ended up coming up in a lot of different classes, even in like Kant class or whatever. Somehow this eventually comes up, the Russell paradox. So, and as I emphasized last night, Carnap at this stage thinks that this is the only way or the only known way to avoid the paradox. Right? Like later on, people discovered that if you are careful with the axioms, you can avoid the paradox without having to use this like type division. Um, but uh, Carnap isn't aware at this stage that you can do that. Um, it's not completely clear even now, I think, uh, whether the theory of types is whether that type of solution is a solution in the same sense that the theory of types is or not. I mean, Quine basically argued that the theory of types is just a particularly inconvenient and awkward way of doing what you can do more easily by just making sure the axioms don't allow this kind of circle to develop. Um, but on the other hand, I think um, if you can make sense of the theory of types, it has the advantage of that it can seem non-arbitrary, that you can like give an explanation of why it really doesn't make sense to say that. Um, Whereas the other main way of avoiding it is it's kind of like just telling you not to say it, right? Like just making sure that it can't come up by not giving enough axioms to allow you to build that set. Which seems kind of like cheating or like we haven't really confronted the problem. I don't know. There's definitely more to be said about this, but the main point is at this point, Carnap thinks this is the way to avoid the paradox. Introduce a theory of types. There's a hierarchy of different types of objects, um, and they, you know, uh, you can't substitute an object of one type in any property that applies to objects of a different type. Um, and I guess, moreover, he thinks this can be justified. And this is an explanation of the type I was kind of hinting at, that you can understand why um, it was a mistake to ever think we could say things like this. And um, to see that, you have to um, buy what Russell called the no class theory, um, which is, and which Carnap definitely buys in this book, which is that you can understand all the sentences that mention classes um, as just shorthand for other sentences that don't mention classes. Right. So again, a sentence like this, let me make it wide. A sentence like this can be transformed into a sentence that doesn't mention classes and doesn't have this set membership symbol. Sorry, that's not right. That doesn't mention classes and doesn't have the set membership symbol, you can just transform it into this. So this was the class. This is the new kind of object we wanted to introduce called a class, a property extension. But you can say the same thing you wanted to say about it without mentioning that new kind of object, just using a predicate. And similarly, suppose you wanted to say that this class is a subclass of this class, right? This is the subset symbol here. Have people have people ever seen like subset and membership and those things? Like, do they still teach that in school?
No.
Yes, they do in the
Okay.
US curriculum.
All right.
Yeah, in like
So
math
I've
curriculum.
yeah, okay.
I've definitely seen it, but I can't
Okay.
promise it was in school.
Well,
Um,
okay. I don't know. Yeah, I guess it does make a difference whether it was in school because if it's in school, everyone sees it. Um, but anyway, so right, this means this is a subclass of this. This class is like, well, so what it means is that every member of this class is also a member of this class. And you can write that without mentioning classes or using the subset symbol, right? You just say for all x, if x is A, then x is B. So far we see how to transform every statement about classes and get rid of the names of classes. Now, this is only two examples. How can we be sure that we can always do this? Um, and the answer, as with a lot of these things, is well, yes and no. It depends what you think you have to be able to say, and so on and so forth. Um, Again, Quine argued that there's really a confusion in Russell thinking you could always do this. Um, um, but it may be that uh, that it looks like a confusion to Quine because of the way Quine thinks about quantification. Um, uh, All right, I'm not going to try to get into the details of that. But in any case, again, at this point, Russell and Carnap think it's been shown that you can understand this talk about classes or the extensions of properties as just a shorthand for talking about their members. And here's two examples of how that would work. Um, and the things I was talking about yesterday with introducing rational numbers would be an example of that, right? That is, each rational number was defined as a, well, I mean, now we had not one place predicates, but two place predicates. It was defined as a relation extension. Um, and yet, like all the normal things we wanted to say about natural numbers, we could get rid of those relation extensions and just talk about natural numbers, right? So like instead of saying that um, that 3/7 is greater than 2/5, we could say something that doesn't mention and where those rational numbers are then defined as relation extensions. We can get rid of the names of the rational numbers, which are now names of relation extensions, and just talk about the natural numbers that are members of those relation extensions. And right, so like instead of saying 3/7 is greater than 2/5, you can say like for all x, for all y, if 7x equals 5y, then 3x is greater than, I may be getting them backwards somehow, 3x is greater than 2y or something like that, right? Um, So what does this have to do with the theory of types and the Russell paradox? Well, um, if you think of this, introducing this notation as just introducing a shorthand for talking about the things that are going to be members of classes. That is the things you could already talk about before you introduce the classes. Then, right, that is, you can't introduce an abbreviation. Well, I mean, so like you can, but it's kind of a joke, right? Like, it's a joke that computer science is like, right? Like there's an operating system called GNU or GNU, which is supposed to, this is supposed to be an abbreviation for news, not Unix, right? So it's supposed to stand for, so you can see the problem with this abbreviation is that when you spell it out, the abbreviation is still there. So you haven't, right, you haven't really got rid of it. And this is funny again. This must be broken. Where do I get a new one of these? Staples, maybe? All right. Anyway, hopefully it won't fall over again completely. Um, right. So like this kind of abbreviation is not really any good. I mean, I don't know. This example shows in a way it is kind of like you can use it for something, but it's not really an abbreviation, right? This it's circular. So like similarly, all the abbreviations that you introduce this way, you have to be able to spell them out so in a way where there aren't any of those abbreviations left. So in particular, like you can't have this can't itself be a possible value of y. Why not? Well, try to expand it, right? So when we when we expanded this for a general y, we got a y. Now, suppose we want the value of y to be this class, right? So then we plug that in, we get, and it's just like that news not Unix example. The abbreviation is still there. We didn't get rid of it. So the thought is that when you see that these are just abbreviations for ways that you could talk before you introduce them, you can see that uh, um, that these things can't themselves be mixed up with those original individual things. Because you couldn't have introduced a shorthand like that, and for this reason, right? You couldn't have introduced a shorthand for talking about things when the things you're talking about already included that supposed shorthand in them. Is that clear? I mean, you can see right here why it doesn't work, right?
Well, I feel like I get it intuitively in that, like, since it's circular, there's nowhere to like enter into it from like another domain or something to that effect. Like if, but like I don't see how this stops. Well, okay. So the set names are being translated into this sort of relation. Um, but like, so we have classes now, but are the classes like just being considered different types of things than their members, and that's what's doing the work?
Well, no, it's kind of supposed to be the other way around. It's like if you think about those things at all, then you have to think about them as a completely different type than their members. Because so this, I think this is the way Russell thinks about it. That's why I call the no class theory. And then I'll say, because how Carnap thinks about it, which is a little bit different. So it's, the reason is that there aren't really any such things. Again, like the fact that these names like this can be eliminated from your language and you can go back to the old one that didn't mention them at all is supposed to show you that there isn't really a different kind of thing you're talking about. It's just an abbreviation for the way you talked about the old things, right? And in that case, you can see here that when you tried to, maybe I should write both the general form and the supposed special application, right? So this is the general um, this is the general strategy that whenever we see something like this, we're going to replace it with this. Let me see if I have another pen that works better. All right, I'll go to war with the pen you have. Um, so right, so like in a usual case, like let's say, Fred is the name of some rose, and I want to ask, is Fred a member of this class? So I know that's just the same as asking whether Fred is A, whatever A is. So far, so good, right? Like A might be is red. So then, let me. Right, this is the class theory version of it that we're trying to get rid of, and we get rid of it by just changing it into Y is red. So if I choose the example of Fred, then I end up with this sentence: Fred is red. Right? So Fred was the name of a rose, remember. So if it's a red rose, then it's true, and if it's some other color rose, it's false. So this works fine, right? And notice this does not mention any classes or sets or anything like that. It's something we could say about a rose before we knew anything about sets or classes. But now the question is, like, give this class itself a name, right? Call this Ned. Right, so Ned is the class of all red things. Red roses are members of it, like fire engines, like every red thing is a member of Ned. And now we want to ask, well, is Ned a member of Ned or not? Now, I mean, that seems to be a question that makes good sense. Right? That's why, remember, when on the way to the Russell paradox, I said, look, it looks like some classes are members of themselves and some are not. In this case, I guess sets probably don't have colors, and so Ned is probably not red, and so it's not a member of itself, but is what we would say. Um, but now try to do this translation thing, right? So we get Ned is red. But what does Ned mean? Well, Ned is a name for this class. Right? So what we're trying to say here is that the class of all red things is red. But this means that our translation didn't work, right? Our translation was supposed to eliminate all the names of classes and class relations, like is a member of and so forth. But no, it's still there. So just like mechanically speaking, right? Like, I mean, I think what's important about this is, at least from their point of view, what they think is you don't have to like engage in some like intuitive speculation about how can you get into this circle or whatever. You just have to notice that this is not a proper way of introducing abbreviation. You can't, if you introduce an abbreviation, there have to be rules for getting rid of the abbreviation and going back to the old way of talking. Otherwise, it's not an abbreviation. So once you decide that introducing classes should really be looked at as just a shorthand, just an abbreviation for ways you could talk without mentioning classes, then you can see that you can't have meant to allow this kind of question, whether net is a member of itself. Because again, you would have been introducing a shorthand which can't be translated back into the longhand. Because the thing that's supposed to be just a shorthand is still there when you do the transformation.
All right, I see that.
Right. So it's just like that example of GNU is not Unix, right? Where when you expand the abbreviation, you find that GNU is still there. There's a lot of things like that, like the email program Pine. I think it stands for Pine is not Elm, because Elm was an older email program, right? So, um, right. So, I mean, that's okay as a joke, but it's not an appropriate way of introducing a shorthand. So that's supposed to show that, in fact, like that sentence that you thought was meaningful, X is a member of X, you only thought it was meaningful because you didn't pay attention to the way names for classes would have to be introduced into a language. If you paid attention to what would really be involved in introducing names of classes into a language that didn't have them yet, you would see that that sentence X equals X is uh, well, it doesn't mean anything. That is, it can't be translated back into the language that we knew we understood. Um, and um, and if your system is set up right, it will be ungrammatical, right? That is, if your system is set up so that all grammatical sentences are meaningful, then X is a member of X won't be a sentence at all. And that's what the theory of types is supposed to establish, right? It's supposed to establish a proper, distinction between different types of variables and whatever to make sure that you never can say one of these inconsistent things like X is a member of itself. Um, and it's supposed to be justified to the reason you're allowed to, or actually like required to, make your syntax such, your grammar such that you can't say such sentences is not like don't say that because it's a paradox, right? It's don't say that because it's meaningless. Um, so on the list of issues that I had, where I had um, basically like logic, ontology, language, and epistemology. what we've just shown is, at least from Russell and Carnap's point of view, I guess I should say, I was going to say how Carnap differs from Russell on this. Russell thinks he's shown that there are no such thing as classes. There really are just individuals. That's why it's called the no class theory. Carnap thinks that that question, are there really such things or not, is metaphysics. It's that question itself is meaningless. You can't construct that question. So, um, and that's going to be important in particular because he's going to say we have a choice of what to use as the basis of our system. So, depending on how you choose, like whatever you choose as the basis, those are going to be the real objects. And then everything at a higher level is going to be the quasi objects that are just going to be classes and relation extensions based on that basis. But he's saying you can choose different things as the basis. So if you choose one basis, you're choosing one distinction between objects and quasi-objects. But if you choose a different basis, you're choosing a different distinction between objects and quasi-objects. That is the same thing, like let's say electrons, that in the autopsychological system are quasi-objects, in the physicalistic system will be basic objects. So, like, it's important not to think of this metaphysically as distinguishing between the real things that really exist and the other things that don't. It's just a linguistic convention that to make sure that whatever you start off with, you then introduce everything else in the right way as shorthand for the things that you start off with. And that means that everything you say is going to all be it's going to be possible to translate it all back into something about one common realm of things. Yeah. John, you have a question?
Yeah, I just wanted to make sure that while I'm reading, I can track. Um, what you had just said about the sphere, the object sphere that you are working in, deciding what is the basic object. I think you said. Um, he uses a term like a he says like your perspective determines what is an individual idea and what is a general idea. Is that like mapping on to what you're saying?
Yeah, that's an example, or that, I mean, um, that's one of the consequences of what I'm saying, right? Because again, the fundamental or basic objects, the ones you start with, are going to be the individuals, and then everything at a higher level is going to be a class or a relation extension, or a class of classes, or a relation extension of classes, or relation extension of relation extensions, etc. Right? So everything else is going to be general, so to speak. Um, And so you might think, so like a different way of thinking about this would be closer to Husserl is, yeah, all of these are real kinds of things, but they're completely different kinds of things. In particular, individuals are completely different from general things. But Carnap is saying, again, that question, is it an individual or is it general? If it's meant correctly, is just a question about how your constructional system is set up, right? You're just asking, does this come in on the basic level or is this something I introduce on a higher level? And in that case, it's relative to your perspective or your decision about how to set up the system, which, as Carnap says, for different purposes, it's convenient to use different types of system, right? So you're going to make that choice based on, that's a practical decision. You're going to make that choice based on what seems best to do. It's not really a question about what's true or false. There's no wrong answer in the sense that one system is true and the other one is false. There could be a wrong answer in the sense that it's a bad idea to use this system form, at least for these purposes, and it's a good idea to use this one. Right? So far, like Carnap, so let's say this is the right way about thinking about the distinction between individual and general, and then you can see from that point of view, like You could say one or you could say the other. It depends on your purposes. But if you want to go farther and ask, no, no, but wait, which one is really individual and which one is really general, then Carnap will say that's meaningless. Now you're trying to ask a metaphysical question. It has no answer. Does that answer your question and show how it's an example of what I was
Yeah,
talking
yeah.
about? Okay. So right, so we've shown according to Carnap and in a slightly different way, according to Russell, that these two things are connected to each other. Right? So Carnap understands the result of the Russell paradox and the theory of types as the solution of the Russell paradox as showing that, you know, part of the way we tell whether a sentence is meaningful in advance of asking whether it's true or false is to see that if it slots into a proper type theoretic hierarchy or not. So if it doesn't, then it's meaningless. And um, it's dangerous to treat it as meaningful if only because you're likely to run into contradictions. There may be other reasons too, but at least for that reason, it's dangerous, right? Once you start treating these meaningless sentences as meaningful, we know that some of them generate contradictions. That's not a consistent way to talk. So we have like a strong connection between these two things. Um, but on the other hand, you know, we can also then explain why it seems now it doesn't really seem this way to people now. So this maybe is a little hard to explain what we're explaining here, right? But why does it seem like things should be divided into different spheres of being? I guess when I say it doesn't seem that way to people now, maybe I mean it doesn't seem that way to most analytic philosophers now. I mean, I think Carnap is right to say that ordinarily we do think that certain things are appropriate arguments for certain propositional functions and others are not. And that if you say, for example, aluminum weighs 5 grams, you haven't said something false. You said something that doesn't make sense, right? Like aluminum is a kind of metal. It doesn't have a weight. It may have a density, right? But it doesn't have a weight. A piece of aluminum has a weight. And from this, you can see that aluminum and a piece of aluminum are objects of different types. Right? So I think Carnap is right to say that we do have some tendency to this in ordinary life too. That this doesn't only come out of Plotinus or Husserl or whatever, that there's a reason that seems to be the right way to think about things. I think, again, it was Quine who really pushed back against that in the history of analytic philosophy and said, this makes no sense. Something either exists or it doesn't. And like since then, people have been like trying to uh, figure out whether we really think that or not. um, uh, these days, I think it's kind of like out of fashion to think that even, but it's still against the background of that being kind of like the simple, intuitive thing to say. But from Carnap's point of view, like, yeah, it seems like there are completely different types of objects, such that what you can say about one type, you can't say at all about the other. It's not just false. You know, another example of that is, and this is in Carnap's mind, that connects this to this. Frege introduced that inconsistent axiom 5. Basically, at least the way he explains in an earlier book why we need something like that is because he wanted to define numbers in such a way that he could be sure that, for example, the number 3 is not Julius Caesar. Right? It's similar to the question I was asking whether the set of all roses is a rose. So Frege thought Yeah, it's the set of the number three either is Julius Caesar or it's not Julius Caesar. Or how do we know which? And he thought that in order to do that, he needed a kind of explicit definition of the number three, and his axiom five was supposed to allow for that. And sure enough, it led to a contradiction. Right. So I think in Carnap's mind, and Carnap actually uses that example in a somewhat later paper that without mentioning that it comes from Frege, but but I mean, everyone knows it comes from Frege. He actually uses that example, like I think he used the example Julius Caesar as is prime as an example of a meaningless sentence, a meaningless metaphysical sentence. Julius Caesar is prime, right? So like in his in Carnap's understanding, uh, that when I think again, Carnap is right to say that when Frege asks, "Is number three is Julius Caesar prime or not?" We're going to say, "Wait, Julius Caesar like prime doesn't apply to things like Julius Caesar. Prime only applies to natural numbers." If you try to apply it to Julius Caesar, you don't get something false. You just get something that doesn't make any sense, right? Is this pen even or odd? Well, I mean, no, right? That I think is our first reaction. And Carnap is saying, and that first reaction is correct. And now Russell has shown exactly why it's correct. It really is true that different propositional functions have different types of argument places, and you can't consistently plug in things that belong in one type of place into the other type of place. And the reason you can't is because, or that's not way to put it. The solution to that paradox, the way that the inconsistency is avoided is by noticing that the sentence was never meaningful to begin with. That what you were trying to force something to a place it didn't belong. And so sure enough, it can't be either true or false. Okay, like so I hope so far so good that it's clear why Carnap thinks these three things go together. Um, Now, what does this have to do with science? So actually, even without going to this epistemological question, this is what I was kind of like, um, um, I don't know, going back and forth about last night, that it does already have something to do with science, even if you ignore this. Why? Well, so we see that different sciences talk about different things, and they seem to talk about different types of things. Right. So even like not counting mathematics as a science now, just take some of the types of sciences that Carnap thinks there are, like physics, psychology, the quote unquote cultural sciences, um, um, which is sort of what we call social sciences, right? The German word is Geisteswissenschaft, but it can it includes things that we wouldn't think of as sciences, like history and art criticism, and whatever. So, all right. So the cultural sciences. Um, so again, it seems like um, if you uh, try to take the objects of one science and apply the predicates that belong to another science to them, at least sometimes you get things that seem like nonsense. Um, um, Although other times you don't. But uh, You don't get things that are obviously nonsense. But I think, like if you ask, um, is this pen angry? You may feel like this pen is not the kind of thing that could be angry or not angry. It's not as clear as the Julius Caesar 3 example. I'm trying to think of a better one. Um, I mean, a problem with this is, and Carnap maybe doesn't put his finger on the reason for this, but like when you say something that could be taken as nonsense in ordinary language, we like usually bend over backward to find a way of understanding it so that it makes sense. So like here's an example. Let's say I asked, how much does Christianity weigh? So if someone seriously asked that, you might think, oh, how can I make sense of that statement? And then you say, well, maybe I should add up all the people who are Christians and all the churches and all the Christian, and then imagine like weighing that whole big collection. How much would it weigh? But um, but I think like on the surface, that seems like it's just nonsense. Um, like it's a cultural institution like a religion doesn't have a weight. You're misunderstanding. Or let me ask, how much does the French language weigh? How big is it? What color is it? Right? Like those seem like bad questions. So it seems like the different sciences each have their own separate spheres of objects that differ in this type respect. Um, and, that might lead you to say that they really have nothing in common. Because remember, the objects they're talking about have nothing in common in the very strict sense that any property that you can predicate of one type of object can't be predicated of all at all of the other type, right? So there can't be anything property that both types of objects have in common. So you could take the moral to be, look, the different sciences are really just completely different from each other, and there's no connecting them with each other. Um, Now, like why that's a bad result, I'm going to maybe try to explain later, but it's clearly something that Carnap really, really wants to avoid. And even when he abandons a lot of the strict methods that he thinks he can use in this book and whatever, he always insists on this, the unity of science. And the idea is that once you understand what these different spheres of beings is, namely that they're a result of the type hierarchy, and there has to be a type hierarchy again because it's the only way to ensure that your language is meaningful. So, the fact that you can't ask how much the French language weighs is uh, similar to the question, the fact that you can't ask whether the set of all roses is a rose, that is, whether it's a member of itself. It's the same kind of nonsensical question. It's just the relationship between the two types of objects is much more complicated, obviously. But they're different types of objects, and the same predicates can't apply to both. But once you understand that that's where it comes from, then you know that in any such hierarchy, there's basic objects, and you can translate everything. Because remember, we're assuming that you can take out all these class and relation extension symbols. You can transform everything back into statements about the basic objects, and so therefore, the very way that the sciences are divided from each other also shows that they're really all united. right? Because they're really all talking about the same basic objects in some sense of talking about. And I think it's important to emphasize this because this unity of science is, I think, it's as important to Carnap, at least as empiricism is. And it's a result you can get without yet, because notice we haven't said anything about some kind of epistemic relation between the different levels of the system yet. Right? We haven't said that the basic objects are the ones we know immediately or anything like that. Any type system that you set up the right way is going to at least have this consequence, the unity of science. Okay, but Carnap does want to do something else too. And that's where this thing comes in about science's right to talk about unobservables. Is one way I want to summarize it. Um, um, so to make this structure address this epistemological question, you have to add this requirement that Carnap calls epistemic primacy. At least that's what it's called in English. And right, the idea is that something is epistemically prior to something else. Like A is epistemically prior to B if we only know B by means of A. Now, so far that's kind of vague exactly what that means, but that's supposed to be the basic idea. And like, so for example, Carnap is the example of the air pressure versus the barometer reading. We don't know the air pressure directly. We know it from the barometer reading. So that's a kind of example of science talking about something that you can't observe directly. You observe something else, and that other thing then indicates what you should say about the real object of discussion here, which is the air pressure. So the barometer reading is epistemically prior to the air pressure. Um, so the Carnap is going to add another requirement to our type system, which isn't justified just by this consideration of logic, right? Namely, that the lower levels have to be epistemically prior to the higher levels. So that's what makes it the case that you can call the basic level, quote unquote, the given, right? Where the given just means the um, the thing that nothing is epistemically prior to. Um, Now, I mean, everything I said has just raised a host of issues that you're probably worrying about, and I'm going to come back to them. But I just want to, just before that, I just want to say, point out how this integrates this fourth problem into this same structure, right? Because now, if you want to ask, well, what gives science the right to talk about certain things that we can't observe directly? And the answer is, well, we have this type system that allows us to translate every statement about those things that we can't observe directly, eventually through many stages, back into statements about the given. And the given, I guess, I mean, like I would understand, and I think to understand it this way helps understand some changes that we're going to see Carnap making later. That the given basically means like whatever it is that we evidently have the right to talk about, that we evidently have a standard that will keep us honest when we try to talk about it. So we can talk about it responsibly, for sure. Where responsibly means like responsible to the evidence. So there's something, the thought is here, there's some kind of objects that it's clear that human beings have the right kind of access to, that they can responsibly talk about them. And now we want to show that because of that, they also clearly have the right to talk about some other type of objects. And the reason is going to be because we actually can transform. Well, actually, is like that's too strong, because in principle, we could transform those statements about those other type of objects into statements about the given. So, like, I'm going to emphasize this, I think, several times in different ways as we go on, but like, it's the purpose of this system is not to actually check, right? Like if I, if I say, uh, um, uh, I don't know, slavery was essential to the mode of production in the Roman Empire. Now, I mean, so if I want to know if that's true or not, like in principle, we had this type system. We could use that. I could use that to translate that into a statement about my own experiences, and then I could check because I have access to my own experiences that as I evidently can talk about them responsibly. I can check. Now, I mean, clearly, if that's possible at all, that thing that it says about my experiences is going to be incredibly complicated. Right? Or to put it the other way around, the process of constructing objects like the Roman Empire out of my experiences, even if I think about the Roman Empire a lot, as some of us do, is is going to be like unbelievably complicated. It's very far from being something that I see with my eyes or something like that, right? So, not to mention that predicate about slavery and the mode of production and whatever, which is going to be even more complicated, right? So, uh, so the purpose of this, although in principle it would allow it, the purpose of this is not literally to go through every statement you want to make and check using your experiences to see whether it's true or not. It can't be used that way. It could be used that way in principle, but in principle means under certain ridiculous fictions. If I had an infinite amount of time to sort through all my experiences and I had a name for each one of them and they were all RDN and so on and so forth, right? Um, but what it does show is that the project of like trying to come to an agreement about whether the Roman Empire, essentially relied on slavery and its mode of production, or whatever what I said, whatever gobbledygook I said, right? Like the process of coming to agreement about that is like it's a task where we have some idea of what to do. And even though we're never going to get to the end of it and be absolutely sure what the answer is, we know how to collect evidence one way or the other, basically. So, I mean, the real way we're going to use this is not deduction, but induction, right? Like the real way we're going to use this is to, you know, collect little pieces of evidence at a lower level for some higher level statement we want to make. And then sometimes we'll go down another level and some of those and so on and so forth, right? And we just collect more and more evidence for one side or the other side, like the way science actually works. Um, but we're guaranteed that that will always be possible because there's a right answer in principle, I think is the idea here. Um, okay, but there's still something else to be, other things to be said about this. So, you might think at this point, even though I kind of already said the opposite of this last night as a spoiler, but you might think at this point, so okay, we understand now um, um, how this can be used to police science. Um, and by police science, I mean like to take things that are questionable, is this science or not? Which now is going to mean, is it meaningful or not? And decide whether, so the way we're going to decide is, we have some kind of suspicious way of talking. Let's say something, to use one of the examples that uh, Carnap mentions, races, right? So this is um, not a random example. It's actually an example of shows what's at stake here and what Carnap is not able to do, which maybe it would be good if he could do. So, right, so let's say we have this talk about races, right? So Carnap mentions Negro and Mongolian are names of races, I guess, right? So we want to know, is this really scientific talk or not? So you might think what we could do is confront the people who are, by the way, I don't think when Carnap uses these examples, I don't think he's a racist in the sense of thinking that one race is superior to another. But what I'm going to point out is that he doesn't really have the resources to say that's just nonsense. There's no such thing as races, right? He has to admit that, yeah, that can be constructed. Um, so you might think you could go up to the people who are using this race terminology and say, produce your constructive definition. Tell us what your criteria are for determining whether something is a race or not. Um, ideally in terms of your own basic experiences, but if not that, then at least at some lower level, right? Um, and then, if they can produce their constructive definition, we'll say, oh, okay, your discourse was meaningful, it's science. But if they can't, we'll say, sorry, your metaphysics. So you might think you could use it that way. Um, But there's a number of ways of seeing that why Carnap's system is not suitable for that purpose. And I don't think he intends it to be used for that purpose. So one is just that, like, part of the in principle here is that we don't actually have these constructive definitions. Right. So like in the later part of this reading, which I know you might not have got to, in the later part of this reading, um, he goes through this kind of sketchy argument about how it must be possible, for example, to reduce psychological predicates to things that are about physical objects. But he doesn't give any details because, as he admits, the details would be very, very complicated, right? Like what pattern of behavior exactly is it that is the indicator for the state of being angry? So that if you observed me showing exactly that behavior, that's when you would say I was angry and otherwise not. And the answer, I mean, obviously we don't know that. But obviously that's way too, if, I mean, Carnap has an argument that we must have such a thing. In a sense, we must be using such a thing, or else we wouldn't be able to use the word angry. But as far as being able to say what it is, that's obviously way beyond our capabilities, at least at present. So, so we don't actually have these constructive definitions. Carnap gives explicit constructive definitions for the very first steps of the system, where he's constructing like, um, different types of psychological entities within me from my fundamental experiences. And he doesn't get very far. And after that, it's all kind of hand wavy. So what that means is that like the race people can't produce their constructive definition, but neither can the physicists. No one can produce their constructive definition. It's all a work in progress. So how did we decide to let these things in as science? Well, it's the right thing to say first here. So rather than having a finished system of constructive definitions, a finished constructional system, and then checking to see whether everything that might be science fits into or not, what we're doing is taking everything we think is science and looking for the constructional system that will tie it all together. We think we have an argument that in principle such a thing must be possible, but we don't have it. And so to speak, our data to start with is the sciences there actually are. Right? And that's why Carnap says at various points, um, like the point I wrote down that's probably the most probably the clearest is in section 17 on page 31. I think there's something similar to this in section 25 on page 41, where he says that the results of the empirical sciences are going to be important tests for our constructional system. So it's not the constructional system that's policing the sciences. It's the other way around, right? The sciences have all these objects and they say things about them. And our constructional system is going to be a failure unless it can find a place for all those things. That's a test of it. So if we come back to those race people, and I mean, this is both a defense of and a criticism of what Carnap says at this point. That is for example, the fact that he, without apparent worry, uses this race terminology. Right. So the defense is that he'll basically let in any terminology that purports to be scientific. So he's not really endorsing it exactly. He's just like the whole posture here is that we're confronted with things that claim to be sciences, and our responsibility is to fit them into the constructional system. So he's not really endorsing any of them because he's not in a position to endorse or not endorse them. That's the data. And moreover, if you ask, how do we know what's epistemically prior to what? Like Husserl will say, we know that by pure reflection, like basically some kind of metaphysical introspection, where we directly see the essences of things and how they depend on each other. But if you ask Carnap, how do we know what's epistemically prior to what? He'll say, we have to, that's the job of the special sciences. Special sciences means all the sciences, basically. It means all the sciences that are not metaphysics. But according to Carnap, there isn't metaphysics isn't a science, so it really means all the sciences, right? So, like, we have to wait for the results of empirical science. That's what's going to tell me what's epistemically prior to what, especially psychology, right? Psychology is going to explain how it is that I recognized someone as angry or that a rose is red or whatever. Psychology, neuropsychology, right? That type of thing. It's going to explain, like, on the basis of what type of states am I able to reach certain conclusions about other things. Um, and when Carnap introduces his choice for the basis, which we're going to talk about next time, he like explicitly cites the results of Gestalt psychologists, which he takes to be like the latest information we have on this topic. So it's not just that the sciences are the data we have to deal with, but they're also like the whole method relies on science to supply us this key information about epistemic primacy. Um, so it's not suitable for criticizing science. It's not suitable for criticizing purported science, right? That is, it's not suitable for criticizing someone who claims that what they're doing is science. Um, unless they disclaim responsibility, right? And that's what I was saying last night about the metaphysicians. The metaphysicians say, no, what we're saying can't be translated into statements about sense data, period. um, then they've ruled themselves out. You can tell that what they're that they're trying to say something, but it's hard to know how to say this. They're trying to say something, but it's meaningless. What's it, right? they're 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 trying to say something, but they're actually just emitting meaningless sentences. Or again, better from Carnap's point of view, they think that they're saying something, but they're actually just expressing their attitude towards the world or something like that. Um, and I said it's a defense of Carnap, but it's also a kind of criticism in the sense that, well, as you can see from that example, um, it might not be such a good idea to just swallow whole whatever concepts something that claims to be science offers up and try to fit them into your system. It would be nice if we had a way of sometimes saying, yeah, these people claim to be scientists, and they claim that in principle, empirical evidence has some bearing on what they're saying, but the truth is that this isn't really science for some reason or other. So Carnap and logical positivists in general don't really have that. Um, okay, are there questions about any of that? I think I've actually kind of got to the end of what I was going to say, but I did it by skipping one thing, which is kind of important. So I'm going to go back to that. Um, again, unless there's questions about this. So again, maybe before I do that, I'll just, kind of summarize what we have going on here. Carnap thinks he's shown as a logical matter why science appears to be divided into different sciences, and yet why they're really all parts of the same science. I mean, maybe that's too strong a way to put the first part. I mean, because he keeps emphasizing it's true. You can't say the same things about the Roman Empire as you can say about a piece of aluminum. You shouldn't think that those sciences are really the same. In fact, they're completely different. They say really different things. They say incompatible things, right? But incomparable things. But nevertheless, they don't float freely of each other. They're all connected into a system. And in some sense, there's a way of like translating them all into a common language, and you can see in principle in that common language, you could see what's true and what's false. So they're both divided and unified. They're both fundamentally divided and completely unified. all that he thinks he can show is like a necessary result of logic, or set theory, at least. But then further, he thinks that you can show, and now I guess the right way to put this is that, like, um, if you ask science, how is it that we can know about different things? You, we can see how to get a consistent answer out of it, even though it's too complicated for us to get now in full. But you can see in principle how it's possible to get a consistent answer out of it, where the things psychology says about what we can know on the basis of what and so forth are are mirrored in the structure and the logical structure of the unified science. I think that, and I think it's the most you can say about this, again, because we don't have a point of view outside of science where we can, like, um, ask ourselves for what for real is given. That's an empirical question. Okay, so that's kind of a summary of how all these are put together. The one thing that I skipped, which is um, not as important as I was just talking about, but still kind of important, is this thing about type ambiguity. So there's a few minutes left, and I just wanted to mention that type ambiguity. I guess I touched on it a little bit and gave maybe a different diagnosis of why it happens than Carnap uh, thinks is right. But so if you think back to, like I was saying, you know, Carnap is right to say that our ordinary ways of talking and thinking do seem to accept that there are type distinctions between objects, right? And the example, which is Carnap's example, is if you say X weighs 5 kilograms, then there are some things that are good arguments for X and some things that are not. Right? So like this pen is a good thing that you can put in for X. This pen doesn't weigh 5 kilograms, so you get a false proposition. But if you took a 5 kilogram weight and you put it in here, then you would get a, or 5 kilograms of potatoes or whatever. Um, we're supposed to go to 12:30, right? I think that's what I put in my, or did I say 12:20?
12:15.
Oh, I said 12:15. Oh, all right. So I won't talk about this. um, uh, thank you for mentioning that, Terry. All right. So in that case, I will end here. Maybe I will say something about type ambiguity next time, or maybe not. Like I said, it's not as important. Thank you for those who showed up, and I will see you the next lecture again is a Zoom lecture on Monday. So I will see you then. Bye.